Strings are immutable character sequences and are represented by the string class in Java. Here is the documentation for the string class. We have already seen how to declare string literals in Java. Here's the data type string. S1 is the object reference, and John Doe enclosed in two double quotes is the string literal, as in many programming languages. And you can assume that it is represented in memory as an array of characters with S1 pointing to the object itself. If you look at the documentation, you will see that string has a lot of methods that we can call: character at, compare to, index of to do searching, last index of, replace, split, and so on. So here is some example code. I would like to go over the example code and then explain some of these methods. Let's start by creating a string S1 with the characters John Doe. So let's print it out. To get the length, the number of characters in the string, we use the length method. This is not a property. So remember, in arrays, we had the length property that used to say the capacity of the array. In the case of string, this is a method. So we have to call length and then open parentheses, close parentheses. And this string has 8 characters. And to refer to these individual characters, we cannot use the square bracket operator. That's what we used to do in C++. Remember, we used to say S1, open square bracket, and then say 0 to refer to the first character. That's not possible in Java. You have to use character at a method. So S1 character at 0, so that's kind of the first character, which is J, and character at 5, meaning give me the 5th character of this string, and that would be D. To iterate over the characters of a string, we have to use a for index loop, and index starts from 0, obviously goes all the way to the length, not including the length, and we use s1.character at I, so to get the ith character, and then print the string one character at a time. There are lots of other methods in the string class. To uppercase gives you a converts all characters to uppercase and then creates a new string. Remember, string is immutable. That means every operation that you are going to see in here has to, if they are modifying the string, if they're trying to modify the string, they are creating an entirely new string with the modified characters. All right, we will never change the original string. So for uppercase, we'll convert all characters to uppercase. To lowercase, we'll convert. We create a new string with all characters converted to lowercase. The original string doesn't change at all. .trim trims the white space characters from the beginning and from the end. So if you have a Janet Doe with some white space character at the beginning and then some white space character at the end, they will be stripped off. So if this were the string, right, the trim function is going to create a new string where there is no white space at the beginning and there is no white space at the end. So this is what we are going to get. Index of, so what is the index of the substring do? It should be 5. And what is the index of substring jan? And it doesn't exist, so that means it's going to return -1. Finally, substring works very similar to C++ substring, except that the second argument is not the length, but the last index, where the last index is not included in the substring. So in this example, substring will give you characters starting at indices. Starting index is 5, ending index is 8, which is not included in the substring. So we will get the characters at indices 5, 6, and 7, and that would be the last name of the person. The last thing, plus operator is the string concatenation, as in C++. It just adds these strings together and creates a entirely new string where all these strings are concatenated one after the other. So in this case, when you concatenate all of these, you are going to get John Doe, obviously. So this is the first string. This string with a single empty space character is the second string, and Doe is the last string. When you combine them together, you get John Doe. So when you have a concatenation operation like this, where every operand is a string literal, as in this example, the compiler in fact performs this concatenation in compile time and creates the string John Doe, during compile time. But if any of these operands is a variable, then that concatenation has to be performed at runtime using the StringBuilder class, which we are going to look at. I would like to take some time and discuss why concatenation using the plus operator is very slow and you should use it very carefully. To motivate that, consider an application where we would like to implement a method that takes a string containing only digits 1, 2, or 3 and returns a new string that replaces each digit with its English word equivalent. Let's call our method digits2words that takes a string, and let's call it as follows. Let's say we feed in a string that contains 1, 3, 2, 1, and we want this method to produce us 1, 3, 2, and 1. So it takes the digit 1 and replaces it with the word 1. It takes the digit 3, it replaces it with the word 3, and so on. So how can we implement this method? Obviously, a very simple implementation would be as follows, and I see a lot of students using implementations like this, and I would like to discuss why this is a very inefficient implementation. So we initialize a string, result is equal to empty string. Then we process every character of the input string, which can either be digit 1, digit 2, or digit 3. So we say if s dot character at I is equal to digit 1, then we append basically the word 1 to the end of the result. If it is digit 2, then we append the word 2 to the end of the current result. If it is 3, then we append 3 to the end. But let's trace this through and see why this is very inefficient. So let's say this is the input. The input string is 1, 3, 2, 1. We start with an empty string. After the first iteration, we are going to take the current string, append 1 to it, and produce a new string altogether. All right. So the new string, the result is equal to the string that contains the word 1. And then we throw away the previous one. Then after the second iteration, where the digit is 3 in the input, we take the current s, or the result, and add 3, the word 3 to the end of it. We get 1, 3. That means we're going to throw away the previous string, and now this is our current result. So bottom line is, if the input string had, let's say, 100 digits in it, then we would be creating 100 strings. At each iteration, we would be creating one new string, and we would be throwing away 99 of them. And the last string that we create is the one that we would be returning from this method. This is very inefficient because you're just creating a new string, throwing it away, creating a new string, throwing it away, and so on. And I mean, does this thing work? Obviously, it does. This is the implementation that we just went over, and here is the test code to test it, and you're going to see that it actually works. But again, this is very inefficient, and you should be very careful when using the plus operator, the concatenation operator. As you can see, it works. I mean, I'm not saying it doesn't work, but it is very inefficient. In here, our input string has only 4 digits. Consider a case where the input string has like 1 million digits in it, then you would be creating 1 million strings, and the length of this, you can imagine the length of the string that you're throwing away towards the end of it. So it will be very, very slow. So observing the need for creating mutable sequences of characters, Java provides a class called StringBuilder. This is the documentation for it. And this class allows new characters to be added or removed from the buffer holding the sequence of characters arbitrarily. This is now very similar to C++ string, which was mutable, as you can see. And after we finish building the string using StringBuilder, we could always convert it to a immutable string object by simply calling the StringBuilder's toString method. That's what we are going to do at the end. And we could just now re-implement the previous problem using StringBuilder. So we instead of creating an empty string at the beginning and then use the plus operator as we did in the previous example, which was very inefficient, This time we are creating a string builder object, and then just doing a string builder.append. So that means we are not creating an entirely new string now. We have a buffer, and so we are just appending the word one to the end of this buffer, or two or three, right? This is very efficient. There is an alternative class that you could use. It's called string buffer. That is thread safe and is therefore slow. Unless you need thread safety, always use string builder in your applications. So thread safe means if you had a multi-threaded applications, you could call string buffer, multiple threads could be calling the string buffer at the same time, and it will still continue working. But string builder will not work in multi-threaded environments. That's what this means. And here is the actual code. So here's this, I call this digits to word 2. So I'm now creating a string builder, and then just look at the current digit. If it is 1, then I'm appending the word 1 to the end of string builder using the append method. If it is 2, then I'm using append 2 to the end of it. And if it is digit 3, then I'm appending the word 3 to the end of it. And at the end, after I create the entire string, then and only then I am calling toString to convert the string builder into a string and return it as the result to the main method. And let me debug this again so that you see that both functions are going to produce the same result. So this is what's coming out from the first implementation, the slow implementation, and this is what comes out from the fast implementation. Bottom line, make sure that you understand how string builder works and use it in your applications rather than using the concatenation operation, which is very slow. As a last note, if I replace string builder with string buffer, this will also work, but it's just thread safe and slow. So unless you have a multi-threaded application and you need thread safety, do not use string buffer. So stick to a string builder. String builder class has a lot of methods that we could use to manipulate the string. Append is one of them. As you can see, append returns a string builder. So this allows us to do method chaining. We talked about this in method chaining, and I'm going to use that in my example. We've got insert that also returns string builders to allow method chaining, index of, what else? Last index of, reverse, replace. So pretty much, substring, subsequence, set length, set character, add. So pretty much everything that you had with C++ string classes, you have it with string builder. Here is some sample code, example code. I am creating a string builder where the content is initially empty. I'm going to print the length, which should be 0, the capacity, the current capacity of the buffer. Then I'm going to use method chaining to append, certain strings to the end of my current string that I am maintaining within string builder. So let's start it. So the initial length is 0, capacity is 16. This means that right now the string builder can hold up to 16 characters, but this is dynamic. So if you were to put more than 16 characters, string builder will automatically increase the buffer that it has. So we start by appending the word integer, then 20. Because this is an integer, it will be first converted into a string and then appended. Then this, then float, and 3.14. Again, 3.14 will be converted to a string and then appended. And here's the actual string. So this is the string, integer 20, float 3.14. So let's find the index of the string 20. So this is my substring. I am trying to find the index of that. That's going to be start. So the start will be pointing to the index of 20. Then I'm going to use replace to replace those two characters starting at 20 with 50. So I'm basically trying to replace 20 to a 50, and I'm again using method chaining. Now I am inserting at position 0 the open square bracket notation. So I would be adding an open square bracket at the beginning of integer, and at position 8. Then I am finding the index of 3.1, which is this. Then I will be replacing 4 characters in here, which would be these 4 characters with 6.28. And now do a toString to get the actual string, and this is the new string now. Let's continue. set character at, so change the character at position 1 to an I. So this basically makes the uppercase I converts it into a lowercase I, and then converts the uppercase F into a lowercase f, and then toString. Now this is your string. So bottom line, there are a lot of methods also in StringBuilder. Just look up the documentation and you can play around with it. Create your own strings. When we write a Java expression involving string concatenation using the plus operator, we know that Java concatenates all of the given strings and returns the resulting string. But behind the scenes, Java compiler actually uses StringBuilder to perform such concatenation as follows. Assume that this is the uh, expression that we write, where we are concatenating a lot of things together using the plus operator. But behind the scenes, to compile, to generate the code for these kinds of statements, the Java compiler actually uses a string builder. So it creates a string builder, and then it says string result is equal to sp.append. So it takes the first string, then append, then append, append. And it basically uses method chaining. And then finally, it uses toString to convert the string builder into the string and then store it in this result. And that's what I did in this example. I have this expression where I'm using the plus operator to create a string and print it. And I know that behind the scenes, it's actually converted into the following string builder and append operations. And I'm going to show you that both of them produce the same result, because that's what the compiler does in the background. So this is what you see from your program, but behind the scenes, it actually creates a string builder, then just appends each and every one of the things that you see, and then creates a string builder object and then converts it to string, and that's how you get the string that you are trying to produce.